Okay, Susan.
And thank you, Susan. Good afternoon, everybody, and welcome to What is the Cloud? I'll give you just a brief summary of what Dave will be talking about today. You've heard the cloud referred to as cloud computing, cloud service. What is it? Where is it? With the growth and evolution of the internet and increased performance has made computing services practical that were not possible before. He'll talk about all the different applications of the cloud, so I won't go on anymore on that because he'll give you a great amount of information on this. But just a little background on Dave, who is my husband, and we are sharing this connection because we have someone else in our house doing Zoom as well, so we want to preserve all the bandwidth we can. He's retired from Spartan Stores. He was a senior vice president and chief information officer for them for 22 years. He had the responsibility for all the business systems, technical infrastructure, communications for that organization. Overall, he's had 50 years of experience in information technology, in product marketing, technical systems management, network management, and worked for companies Hewlett Packard and General Foods. He has extensive network management experience, communication technology, strategic planning, and many other things. He holds a bachelor's degree in business administration and master's degree in computer science from the University of Arizona. So I'm going to slide over and let my husband take over this connection.
Good afternoon. Let me get my screen in a sharing mode and get my presentation up. So I'm gonna, can everybody see the slides?
We can see it.
Okay, good. All right, so we're gonna talk about what is the cloud. And so, hold on, I gotta click it. Okay, so we're gonna talk a little bit about what the cloud is, and the sort of the history of how it came to be, the different inventions over the last 40, 50 years that even makes this possible. And then the real action is going to be talking about how the cloud is used in the business world. And then I'm going to spend probably, I'm not sure, about half the presentation on how we as individuals or people outside of business can use the cloud for our own purposes. So that's going to be the essence of the presentation. So talking about what is the cloud. So the cloud it's kind of a confusing term. It's used to describe a group of servers, computers out on the internet that are available for people to use and companies to use for a variety of purposes. It's not a physical thing. It's much more of a concept. It's a network of servers. They could be anywhere around the world. They're all hooked together through the internet, and they operate as a single system. They're designed to do a lot of different things, and we're going to talk about those different things. You can store and manage data out there. You can run applications, and we're going to talk about some of those. You can deliver content or service. And those things all listed there. We're going to talk about those and more as we go through the presentation. So if you think about this, because people have experience using a computer on their desk, using a PC, or maybe if you were in a business or you're a more sophisticated technical person, you might have a server at home, and you're accessing that's sort of traditional. But if you go to an environment where you're accessing information online, so you have files stored out on the network, out in some service out there, and you can access that same information from your laptop, from a tablet, from a smartphone, and you're accessing the same information. It's not like it's stuck on one particular system. You're using the cloud. And there's a thing called Internet, IoT, Internet of Things, and that's evolving the number of devices that use this environment. But the point is when you have the data out in the cloud, you can access it from anywhere and anytime. And so it's a pretty flexible environment, and we'll go into more details about that. So if you were to draw a simple diagram, you'd say, hey, there's these computers and there's applications that you use and databases that are out in some data center somewhere. And because of the capabilities of the internet, I can sit at my cell phone, smartphone, tablet, computer, whatever, and access that information. And we'll talk about that in more detail. So where did the name come from? So having spent 50 years of my professional life designing and building computer systems and communication systems, the cloud started off as kind of a slang term. So when you're building these things, you build networks and computers and so forth, you do drawings, you build these drawings, and they can be quite complex. And so if you're trying to talk about something and you assume that network and those servers are there, but what it is you want to talk about is something on a PC or something that's using that network. You have this large complex diagram, and I have one on the lower left here of a segment of a network, and that's a pretty small segment. You don't want to draw all that stuff on every diagram, and so technical people started the habit of, well, I'll draw that whole network thing as a cloud. And so whatever it is I want to talk about, I'm accessing the cloud. And so the simplest way to draw the diagram was to draw a cloud. And so to simplify complex diagrams, it became popular to do this. Well, then and so whether you were building a corporate network or you were talking about the internet, you would draw it as a cloud. And so you started calling it the cloud. And as more computer processes, more people started moving applications and so forth out to these data centers on the internet, people talked about moving to the cloud. And so today, you know how the press is, and they all pick this stuff up. And so everybody's talking about the cloud, and marketing people are talking about the cloud. But that's what it is. It's a network of servers that are out there that are available to do lots of different things. And we're going to talk about that as we go through it. But that's, if you want to know where the name came from, it was a bunch of geeks like me. We were all drawing stuff and how to simplify things. And so we just started drawing clouds, and it became a popular thing. So now what I want to talk about is the history of how we got here. And so a whole lot of things got created, were invented over time in different eras that have all come together to create the possibility that you can do this kind of computing over great distances with massive amounts of computing power that allow us to do things in a simple, what we as human beings view as a very simplistic way of accessing data, and it's in the quote unquote cloud. So we'll talk about some of these technologies that came along over different periods of time. So time sharing. So if you go back to the 60s, when I was in high school and I started working on this stuff, computers, the kind of computers I worked on looked like this. And they were generally at that time, they were computers that were, they weren't sophisticated. They were powerful for the day, but it's your watch has more power than they did nowadays. But they tended to be, when you wanted to do something, the whole computer was devoted to doing whatever it was you wanted to do. And so one of the first things they did was to be able to share that expensive resource, because of course these things cost enormous amounts of money. And so instead of having all that money be dedicated for one thing, how can we share the resource? And so they came up with a technology called time sharing. So there they attached terminals. Terminals hadn't existed up until this point in time. And well, I won't go into the details about terminals, but anyhow, terminals connected to the computer, and they would take the the processing capability of the computer and divide it up amongst the terminals. So for example, if you had 1 second of processing power and you had 10 terminals, each terminal would get 1/10 of a second of that computer's resources to run whatever it was you were working on that terminal, whatever it was you were trying to do. And so time sharing was invented, and this was back in the mid 60s. Well then, and we've talked about this in the internet class we did a while back, the internet got created. Now the internet went through a lot of stages in history, but the original concept was, they came up with it in about 1962. And that concept was expanded, and they built the first device in 1965, an imp. I won't go into the details. But then through the 70s and the 80s, different, I'll say, not invocations, but different networks appeared that had different focuses, but they all blended together and became the internet. And things like the World Wide Web, web browsing and so forth was created in 95 and so forth. And so all that led to creating of the internet. And so there's a couple diagrams of what the ARPANET, which was the predecessor to the internet. In 1969, there were 4 universities that connected their computers together. You can see in 73, they had quite a few more. And then by 82, they had a fair number. And this was a way to share research information between universities, and their research groups were able to start sharing data. So all that grew and it grew. And this is an example of, not an example, this is a diagram of the fiber optic connections of the internet backbone. Now you'll see areas of states in the more rural areas and so forth where you don't see any lines. Well, this is just the backbone of the internet. There's lots of subnetworks that exist that aren't on this diagram. But the internet became this backbone, and these fiber optic connections provide enormous communications capacity. So you can see what happened. This graph shows what happened to communication speeds that made this possible. Back in the day, when you would build data centers, I'm going to show you a couple pictures of data centers back in the day that you would build, and devices that attached to that computer system had to be in the same building or on the same campus, because communication speeds weren't that great in terms of the ability to certainly connect someone's home, but even to connect different business sites around the country. And so as communication speeds increased, all of a sudden it became possible to have computing capacity that was in a given location be able to be accessible anywhere. And now it's become so incredible with cellular technology and the fiber optic systems, we can bring an enormous amount of computing capacity. I always say to your cell phone as you're driving down the highway 70 miles an hour in some freeway somewhere. So the communication speeds were critical to making all this work, and the ability to have this enormous processing power basically available in your hands from many, I mean, I don't know what the percentage of locations on the earth, but and certainly in populated areas, it's amazing what speeds you can achieve. So that was, the building the network, being able to share computers, and being able to gain huge, have an enormous communication capacity to locations were all critical elements of this. Then there was a next thing, if you kind of go beyond time sharing, this is a little bit more complex environment. So on the left, you see a computer, and this might be your PC that you're using at home. And maybe that operating system is Windows, and or maybe it's Mac OS. And those apps you might be running, if you're in the Windows world, maybe you're running Excel or Word, or if you're on your cell phone, maybe it's some app that you like, or if you're in Microsoft world, you're using Pages or some other thing. So you built this operating system that ran on computer hardware and managed the different applications. Well, in order to be able to use this hardware and have it be shared amongst a lot of environments, they created a technology called virtualization. And so if you look over on the left, you took that same physical hardware and you put a layer in the middle, and it was called a virtual machine. I'll just call it a virtual machine operating system. And then on top of that, you could put your copy of Windows, your copy of Unix, your copy of Linux. You could put different operating environments. And so that's what VM0 and VM1 are. And that operating system thinks it has the whole computer to itself. So it can run various applications and do various things. And that virtual machine monitor it gives it sort of a capsule of, here's this computer and I'm going to manage the difference between all these things. Well, so you see these two different environments, and one could be Windows and one could be Mac OS, or lots of different environments. And so if you extrapolate that and build that environment and allow it to do thousands of virtual machines or hundreds of virtual machines, all of a sudden you can have a computing resource that can be shared by many, many people. And they think they're presented and their software runs an environment that only they can see, and it's encapsulated and is able to run without one virtual machine talking to another. So that was a very key invention that was created that is essential to making the cloud work. So now we've got high-speed communications, and we've got the ability to share and have multiple people, it's like multiple renters in a house, have a part of the environment. So virtualization was very key. So then, and I tell you, this could be a HASP class by itself. So now we're going to talk about the speed of computers. And I don't know if you're familiar with how chips are made and the processor that's in your cell phone or in your tablet or in your PC, but this is what they look like when they're being manufactured. And back in the day when my wife and I were involved in this business, these things were like 6 inches in diameter. And you can see by the picture in the lower left that sorry, the word's escaping me at the moment, but that platter that's built is now around 12 to 18 inches in diameter. And if you look in the middle, you'll see that it's etched. They've etched the chips on that substrate, and you can see there's, I don't know what that number is, but let's say there's 120 chips that are on that wafer that is created, that is where the chip processing it, how it's manufactured. And that's basically a wafer of silicon. And so they etch the lines and the components into those things, and then they literally cut them up. And in the lower left, they take the cut up chip and they put it in a packaging thing that allows you to get all the electrical contacts in it. And you can see sitting on the platter are 2 chips on the right that have been packaged up and ready to be installed in a computer. So again, in a very high level way, that's how chips are made. And this is a chart, I'm going to get a little geeky on you, but this kind of tells the story of what's happened with the creation of these processors. And so if you look across the bottom, you see time going back to 1970, around the time when the integrated circuit was created, to 2020. And they've mapped onto this. I really love this graph. I discovered this one as I was putting this presentation together because it tells the story. The data it was originally a graph that was created in 2010, and then somebody took the graph and extended it to 2015. So what you're looking at is over on the scale on the left, you see that it's order of magnitudes of increase in numbers on the left and time on the y-axis at the bottom. Sorry, at the x-axis in the bottom. So we're going to talk about the 5 different groupings of points. So the brown triangles that you see at the top are the number of transistors that they can put on a chip. And a transistor is a fundamental electrical component that does the logic of adding and subtracting and comparing and the different functions that occur. They're built up with combinations of transistors and some other components, but transistors are the key piece. So you can see how the number of transistors over time has continued to increase. The second grouping of blue dots is the performance, is how much processing that chip can do in doing calculations. So how many additions, subtractions, comparisons, multiplications, division, all the different mathematical functions and logical functions that occur, and how fast can they occur? Well, what you notice is about 2005, up until 2005, the speed with which the chip can do processing kind of increases. But then starting about 2005, it starts to level off. And so they start to run into a physical problem. And the next two graphs explain it. So the next thing is a group of green dots, which happen to depict how fast the chip is processing. So when a computer does work, there's a clock, and the clock ticks. And every time it ticks, it adds two numbers, or it divides a number, or it compares two pieces of information. It's the timing that controls what goes on in the computer. And that's represented in the frequency. So you also see that the speed with which they could clock these chips, the processors, it continued to grow, but then about 2005, it leveled off. And so they were running into a problem, and they were hitting the laws of physics. And likewise, you see the typical watts of power. So the faster the clock goes, the more energy it takes to drive the processor. And so that creates heat. And so those three things in the middle, the speed, the clock rate, and the power that's consumed, the smaller the chips got, the closer the lines got, they ran into physical limitations, and they couldn't keep the electricity in the lines, and it would jump from one line to the next because the lines were too close to one another. It started generating too much heat, and they couldn't cool it enough, so it would just literally melt down. So all these created problems that they couldn't make the chip any more dense and increase the processing power. So then what happened is the bottom line was the solution. They said, okay, instead of building a chip that does everything serially, 1, 2, 3, step by step, we're going to add more cores or processors so that it does. So because we've run into the law of physics, now we're going to be able to do multiple things at once. So when they went from 1 core to 2 cores, it could add 2 numbers at once. Or it could do an addition on 1 core and a multiplication on another core. And so as they started increasing the cores, they were able to increase the computing power and still keep the heat and the clock rate and the performance of the individual, and still work within those laws of physics. The catch is software now had to be designed to run things in parallel. Software had to get a lot more complex to determine when multiple things could happen in parallel. All of that said is what's created the incredible power of a chip that they can put in your phone, and the amount of computing power that is in your phone, in your laptop, and now on these massive data centers. So sorry to geek out on you a little bit, but I thought that would be important to sort of understand the challenges that the electrical engineers have had to try and build these chips and the different issues they've bumped into in time. So these are a couple of data centers actually that I was responsible for. I built them back in the day. So in 1984, on the left, you'll see 2 pictures of a data center that was in Colorado. I can't remember, I want to say it's about 5,000 or 10,000 square feet. There was 21 computers in there. That was a pretty good sized data center at the time. And you can see the operator area down below, see the mag tapes, all that stuff. And so that data center had 21 computers. On the right-hand side, before I retired, this is what the data center looked like that we were running where I was before. That data center had about 1,000 processors in it. And physically, you can see there's actually a fair amount of space in there. We could have probably pushed it maybe up to about 5,000 processors. But the important thing to understand here, and the difference, is that in that room in 84 that had those 21 processors, one of those 1,000 processors in the data center on 2018 on the right, one of those processors was as fast as those 21 machines back in 1984. And so a huge increase in processing power. But these data centers are tiny compared to what the cloud and what we're talking about. So just as a quick look here, when they build these servers and put them in these data centers, there's the 2 drawings, the 2 pictures on the left are of servers that have all the stuff to support keyboards and displays, have storage and so forth. But when you build one of these massive data centers, you don't need keyboards and displays because those are all sitting in our hands. All you need is the processor and memory. And so that's when it looks like what you see on the right. And so once again, that single processor that you see slid out of the card cage, that could do more than what I did in 1984 with those 21 machines, a massive amount of processing power. So in cloud data centers, this is what they look like. And so you look at the bottom, and that's one of them is an Apple data center and one of them is a Google data center. The other ones are I don't know where they're from, but those are real data centers. Those are what cloud data centers look like, and the cabinetry and cabling and so forth that exists to make those things work. And they're anywhere from 200 to 350,000 square feet. Remember, I said those two corporate ones that I was involved with were 5,000, 10,000 square feet. And they have between 70 and 80,000 servers each. So these data centers are massive. And so utility access is a big deal. There's a whole lot of dimensions. Now, they maybe only take about 50 or 60 people to run them. But they're massive amounts of computing power. And so if you talk about the cloud, here is Google's cloud. Now this picture is from 2010, I believe. So it's grown a lot larger, but you look at the green dots, and the green dots are data centers that they have, and it shows you the number. So they have 2 in Oregon, for example. And then the blue ones were ones back in 2010 that they were going to build. And so you can see they were going to build 3 in California, and you can see over on the right, you can see there are 3 that existed at that time in Tokyo and so forth. And you can also see all the fiber optic cable, the fiber optic cable in the ocean that links these data centers together that allows Google's cloud to operate. And so when you do a Google search and you hit enter, that search is going to the data center nearest to where you physically are located. The data is replicated across this thing. But you can see it's a massive investment. When you think of each one of those numbers representing a 200,000 square foot data center with 70, 80,000 servers, it's massive amount of processing power. And this kind of just exemplifies that. So this is the quarterly spending to build. These are called hyperscale data centers. The dollars here on the left are in billions of dollars that these companies are spending to build these things. And in 2019, the top spenders for building these big data centers was Amazon, Google, Microsoft, Facebook, and Apple. Down at the bottom, you see Alibaba, you see Tencent, those are Chinese companies. You see IBM, Oracle, and so forth. They're not even close to what these guys are doing. Now, a little story about Amazon, depending on how much you pay attention to what goes on in Amazon. Amazon originally built their data centers to handle their retail business. But the retail business, as they built these big data centers, as it grew, they go, you know, we've got these big data centers, we could sell this as a service to others. And so they started a business where they sold their processing power in the complex as cloud services to companies and to individuals. And so if you look at an earnings release from Amazon, and you look at their quarterly results, what you'll discover is that they make about 1/3 of their profits from their retail business. 2/3 of their profits come from selling these data centers, selling processing time on these data centers. And they are by far the biggest. We'll see, I think I've got another slide come up in a minute to explain that. So it's estimated there are around 600 of these hyperscale data centers around the world. These cloud data centers, if you will. There are 39% of them are in the US. This was as of the end of last year. You can see how it breaks out from the various countries. So the US is by far the largest, but you can see how it's grown. I mean, 600 of these things, it's a massive complex that you have available to you from your laptop, from your phone. So let's talk a little bit about cloud in the business. We'll talk about data centers and the concept of a business, and should I even own a data center going forward? We'll talk a little bit about the cloud, a high level view of cloud services. Talk a little bit about the software providers, and we'll talk a little bit about the marketplace. So why do you use it? Well, it's incredibly convenient. You can access it from anywhere. It's incredibly reliable. For example, if you store something in the cloud in one of these data centers, behind the scenes in those virtualization environments, they replicate. So if you save a file or save a contact, for example, it saves it not only in your primary data center, but it replicates it in 2 or 3 others. So there's backup copies. So if they have a failure in one of the data centers, they're covered. They have the data is replicated in others. So it's incredibly reliable. You do hear about outages. You'll hear about an outage Amazon had on the East Coast and websites were affected. I think one happened a few months ago. Over the last year, I think there's been about 3 or 4. So it does happen, but it happens in corporate data centers as well. And it's less cost because it's huge leveraging of the volume. And we'll talk more about that. So if you think about traditional computing, and you saw an example of a couple data centers there, if you're company A, you build a data center and you have machines that access that data center, and another company, Hayworth and Herman Miller and Steelcase and Spartan Nash and Meyer and Spectrum, we all have data centers. But now what's going on is in the cloud computing model, in theory, you don't have to build a data center anymore. Now you go to one of these cloud data centers, you use the internet to communicate with it, and you can still do all your same computing, but the computers are in these large data centers. And I would tell you, if my career was starting over right now, and I was in a small company starting up, the amount of hardware that I would have to invest in terms of building a data center, I'm not even sure I would build a data center because you can do it all in the cloud. Now you get to a large company and there can be some nuances that make it an issue, but in general, it's really changed the landscape in the last few years. So here's a chart that kind of shows the dollar side of things. So if you look at an enterprise, look at the blue at the top. So you got time, and you can see this is projected out through 2006. So you look at enterprise IT operational staffing costs. Well, that's the blue, and so you can see that going down as people move to the cloud. The red is public cloud infrastructure, the hardware and software spending. So the money that they're spending to support business, and you can see how that grows. I'm going to not talk about the private cloud spending, that's a nuance, but then the green is traditional infrastructure, hardware, software spending. So back in the day, and I showed you pictures of building those data centers, the amount of money you would spend now versus what you're going to spend in the future is significantly less. So let's talk about types of cloud services. Now, this is the business. This doesn't, in the business world, it's less about how we as private individuals operate. We'll talk about that next. So there's 3 ways you can buy as a business. You can buy this service from these cloud data centers. The first one's called infrastructure as a service. And basically there you buy hardware and you buy storage. What you do with it, they don't care. I say, I want to buy 1,000 servers, or I want to, rent 500 servers. So they'll carve out and say, okay, you get servers, 1,005 through 1,505, and those are your 500 servers. And then what software, what operating systems, what functions you do with them, they don't care. They're just, the hardware's there. They'll make sure they have power. They'll make sure if one fails, they'll replace them. And this, the write-up kind of talks about, it's like a company leasing a plot of land in which they can build whatever they want, but they need to provide their own building equipment, materials, and so forth, is kind of an analogy. Then platform as a service is kind of the next level. So you buy not only the hardware and the storage, but you also then, if you're going to run Linux, or if you're going to run Windows, or you're going to run the Oracle database, or you're going to run some other database, the services that you need so that you can build whatever program or system you want to build, those basic level software services are provided. So you get the hardware, you get the storage, you get the operating system and so forth. And then you can build an application or build some piece of software that does something. And again, it's like renting all the tools and the equipment necessarily to build a house instead of renting the house itself. And so I'm going to go build something, but they don't care what it is. And then final case is the most, one of the cases you hear about the most is called software as a service. And in that case, you say, okay, I need a financial system. I need a general ledger, fixed assets, accounts receivable, accounts payable. And I go to a company and they lease to me over and I pay for it. I always say we pay it by a drink. So every transaction you negotiate some agreement and they provide the financial system. So you need PCs on your desks for your financial people, but they're all connecting through the internet to some cloud data center somewhere and they're running the financial system on that cloud. And that runs the financials for your company. Now you can see if you do that, you've made a huge commitment to that particular company. So the negotiation for that contract, because walking away from something like this is not trivial. And so negotiation and contract negotiation in the computer business is a discipline in and of itself. You have to be very careful because you say a 5-year contract. Well, are they going to be able to increase the price in 5 years? By how much? And so forth, because you're making a huge commitment. So anyhow, those are the 3 levels of service. When you go to the cloud as a business, those are the kinds of things that that you look at. And when we were in business, we used all 3 of these. And yet we still had that data center with 1,000 servers in it. So anyhow, but that's how a business approaches it. These are all the companies that are out there, and there's actually more. But I'll give you 2 examples. In the middle there, there's a blue cloud called Salesforce, very company that gets a lot of press coverage and so forth. They make a system that allows you to track all your customers, bill your customers for whatever services you're providing, keep track of customer contacts, do everything, keep track of sales, look at trends and so forth. It's a very comprehensive, and there's a lot of add-ons to it, a very comprehensive set of tools that if you need a system to manage customers, Salesforce is a place you would go and you would buy their software as a service and away you go. I'll use one other example over on the right. You'll see something called Concur. Concur is to do expense reporting. So if you work in a business and you're an employee in a business, you may travel, you may not. You may when you travel, you go to stay at hotels, you go to restaurants, you fly, and Concur has all the tools for a company to do all their travel requests, do their expense reporting and so forth. And where I worked, we used Concur. And so you would log on to Concur and we had it tied into our financial system, into our payroll system. So it knew who you were. You had credit cards that the credit card transactions would be fed off into Concur. And so you had a card and you had to say, well, I use this credit card for this purpose and so forth. And then once you'd filled out your form electronically on the system, you would submit it to your supervisor and your supervisor would approve it and off it would go to finance. So anyhow, you can go across the list here and there's all sorts of functions that are available that are software services that are available in the cloud. And so you as a company don't have to build that software. You don't have to maintain that software. You don't need the computer systems to support it. It's all done out in the cloud on the data centers. So what's the marketplace look like? Well, so if you look at that top one, AWS, that's Amazon Web Services. And you can see they have 32% of the market. So going back to and this is at the end of 2020. So, and this is, by the way, the infrastructure of those 3 levels. This is the first 2. It's hardware and storage, and then that base level software. The applications you run on doesn't matter for the purposes of this graph. So Amazon has 32% of the cloud market. And so while we all think of Amazon as a retailer that we buy products from, 2/3 of their profits come from AWS and selling AWS services. It's called EC2. is how they refer to the how they refer to the environment, the server environment and so forth, which stands for Elastic Cloud Computing. The 2 is 2 C's. So Elastic Cloud Computing is the technical environment that they're selling. Next one down you see is Azure. That's Microsoft. Microsoft, while they made an enormous amount of money selling us Microsoft Office and Windows, they saw this market as big and they invested in it early. And so they have a very sizable presence, and Azure is their marketing name for their cloud service. And then there's the Google Cloud. We all think of Google as a search mechanism, but they have computer centers, big data centers, as we saw in the diagram, and they sell that as a service as well. They're an interesting company to deal with. I mean, we could have a long conversation about this slide. Anyhow, Alibaba is, if you will, kind of the Amazon of China. Then you see IBM Cloud, then you see a Salesforce. That Salesforce piece is just, that isn't selling their software, it's just selling their data center services. Tencent is another Chinese company, and then Oracle they're down to 2% in the market. So anyhow, that's a little bit about how the cloud marketplace what it looks like. And applications, and we'll talk about them, could be running, applications that you use, that you're using today, could be running in any one of these environments, or it might be running in some other cloud environment that's not represented here. So in the rest of the talk, I'm going to talk about the cloud for the rest of us. Talk about why you use the cloud, what services can you use, talk a little bit about the product ecosystems. Those last 2 bullets are kind of interlaced, but that's where we're going to focus the rest of the conversation. I haven't even looked at, I don't know if there's any questions or so forth. Susan, can you? Well, I'm going to keep going. Nothing's jumping out at me here, but we'll have plenty of time in the end. So the cloud for the rest of us. So let's talk about that. So why would you use it as an individual? Well, one of the biggest things is collaboration. And I've worked with different organizations, individuals that maybe aren't part of a business, but they're working on something together. Maybe it's part of their church. Maybe they're on a mission. Maybe they're on a board of some other group or whatever. And so if you all want to work on stuff together and share documents and so forth, collaboration is very key to working in the cloud environment. Information accessibility. If you want to be able to get at it from any device, from anywhere, putting it in the cloud is the way to go, because you aren't tied to a hard drive on a PC or a given device. It's accessible to anybody. Data protection. Data protection is very key. As I mentioned, when you store something in the cloud, given that the company has set it up properly, all these data centers, they replicate stuff to multiple data centers, so there aren't risks. And it's highly secure, so you can be pretty content that your data is well protected. And then one of the things that, is if you have a PC and you have Microsoft Office, or you have Quicken, or you have different things, you're constantly having to update the software. And so when you do things in the cloud, the cloud software is generally automatically updated. And so you're kind of usually running on the most current version as you go. And it's just easy. And so we'll talk about it as we go further. So am I using the cloud? And probably, well, I know everybody is, because we're all using Zoom. We'll talk about Zoom in a minute. Because Zoom is a cloud-based video conferencing service. But of the other things you do, you can ask yourself a simple question. Can I log onto the service from different devices and see all of my stuff? So if I'm using a smartphone, today or tonight, I go home and I'm using a computer, or I have my tablet, and if all the information that I'm accessing is the same, you're most likely using the cloud. And so it's the difference between having a PC and having files on your PC versus having files in the cloud. So we'll talk more as we go. So here's some of the different services we're going to talk about. We're going to talk about email, one of the first cloud services that ever existed. Talk about video conferencing, what we're doing right now. Talk a little bit about social media, desktop applications, storage, backup, photo storage, music streaming, movie streaming. There's others, but I thought these were the ones that were kind of important to talk about. So I call email the ultimate cloud service. So email was originally built. Everybody started using it at different times. I started using it when I was at Hewlett Packard in the late 80s. And the switching of email between different servers and so forth, that's all goes on across the internet. And the service you use is running in some cloud-based data center somewhere. But how you use it, there's a little bit of a difference here, a little nuance. And so, for example, you could be using email off your laptop, off a laptop or a desktop, and all your folders and all your files are on that desktop and not in the cloud. And so in that particular case, if you want to get at all your stuff, all your email folders and things you've kept, you have to be on that PC, as opposed to running a different type of email or a different interface. And these are a couple of IMAP and POP or some technical interfaces to email systems. But basically, if you're running IMAP, you're running in the cloud, in that all your folders, all your email is sitting up in the cloud. I happen to use Gmail, and people use different things, but I can access my Gmail account from my phone, from my tablet, and from my laptop, or I can sit down at a browser somewhere as a service and access it. And all my folders, all my files are sitting in the cloud in the Google email system. And if I want to download it to one of my machines, I can, but all my email and all the copies of it, my folders and so forth, that's all in the cloud. And in my case, I converted to Gmail and so forth when I had the opportunity to travel to China, and my wife was here and family was here, and I wanted to communicate with them. So I didn't know what kind of computing capability I'd have over there. And so I wanted to be able to walk up to a browser and communicate with them. And so that's when I made that conversion. So anyhow, a little bit about email. And there's lots of email services out there. There's Gmail, there's Microsoft Outlook, Apple has a mail system, Proton's a good provider, Yahoo's been around forever, and of course AOL is one of the first. And of course, there's always the joke about us that you can tell someone's age by which email service they're using. If you're and just because of what we started and where we started to, what email system we started to run and what we were accustomed to. And you can see that a lot of these services provide free access, and you only have to start paying for it if you want more storage or you don't want to see ads. And the Apple Mail, the reason I highlighted that is that's actually the iCloud service. And so that's sort of the entry-level price. So anyhow, a little bit about email. Video conferencing, the thing that we're all doing today. So what you're doing today is I'm sitting here talking at a PC, and I am sharing my screen. And so my voice and my screen is being sent up to the Zoom cloud data center. And then if you have your video on and you have your audio on, if you don't, it sends whatever you provide up to the Zoom data center. And then Zoom, based on how you choose to view, if you have it in gallery view or speaker view or whatever, that cloud data center that Google runs turns around and reflects back to you the audio that it is determined is the primary audio to send and the video to send. And so Zoom is doing all of that in the background. And you can interface with a Zoom video conference with a laptop over down the lower right, a tablet, a desktop, or your phone. And it will do all that processing. And you can also take, and Zoom is shown on the left, interface other video systems to Zoom. there's software room systems. For example, when we go back to HASP classes in person, to keep Zoom going, we will set up the classrooms with the necessary hardware and software so that you can be in the classroom or you can be home and still see and participate in the HASP class. So, and there's lots. Zoom is, you see, Zoom has become very popular. If you're in the Apple world, you probably used FaceTime, again, another cloud video service. Facebook Messenger is their video capability. You can see Zoom. This was a survey that was done in the first quarter of last year of what different video conferencing applications people were using based on whatever sample size they had. So you can see FaceTime, Facebook Messenger, Zoom, Skype. Skype's an open source video conferencing. It's been around for a long time. WhatsApp is an app that you can communicate with. Google has their components. Microsoft in the Azure world, they have a thing called Teams. And so forth. And so there's a lot of video conferencing, and there's GoToMeeting, there's Cisco WebEx, there's a variety of them that exist, and they're all cloud services. They're all take connections from all over, take them into that cloud data center, parse them apart, and send out the information based on what's needed. Social media, I'm not going to spend a lot of time on social media, but these are basically cloud-based services. I'm not a big person. I mean, I do, Twitter and Instagram. I'm not a Facebook person. And I've done LinkedIn because of my professional career, but all those are cloud-based services that you have an ID, you can load up pictures, you can do a lot of different things. And so that's another cloud-based service, but I'm not going to spend a huge amount of time there. Now, some of these companies have what I call ecosystems. So Microsoft, if you're from the Microsoft world, you know about Word and Excel and PowerPoint and Access, maybe some of the others here, Outlook from an email and a calendaring standpoint. Knowing that the cloud technology was becoming a thing, they created Office 365. Office 365 is a set of software you can install on your computer. You can install it on your phone, or you can run it in the cloud. And if you run it in the cloud, all your files, all your information that you're running in these applications, you just walk up to a browser, you log on, and you can bring up Excel, or you can bring up Word, edit documents, save documents. You have folders in the cloud and in the Microsoft data centers. And so that's Microsoft's cloud ecosystem. Google, I use a number of these.
Excuse me.
Yes.
Dave?
Yes, Tom.
I had experience with Microsoft Office. I had bought a laptop and I got Office 360 with it for a year. And
$99 a year.
Yes. And I had nothing but trouble. I was using a VPN at the time because I wanted to use my machine when I went on travel and so forth and be safe with it. And the office would, when I'd sign up, the office would say, "We don't know who you are," and they would shut it down. And I had spent about a week working on a research paper that I was writing, and they eliminated it. I mean, it disappeared. And
so were you using a company laptop?
no, I was using my own.
Okay. The VPN plays a role in that. That's when you do VPN, depending on how you're doing it and the service and what they're accustomed to connecting with, VPN, because of its encryption and encapsulation, it might not have recognized who you were because of that. That's a long conversation we can have at another time, but the VPN is probably what was causing the problem.
I contacted Microsoft about it. Yes, at the time I didn't know why it wasn't working, and they did a lot of stuff. And finally, it came out that they figured it was the VPN that was causing the problem. But the situation I have with that is when I'm say I'm in Maui in a hotel, the Wi-Fi there is public, so I need to use a VPN. So does this mean then that I can't use Microsoft's Cloud Office because I have to have a VPN involved?
No, you could, there's things you can do you definitely can use VPN. It's just, there's certain things you have to set up a certain way. And so, you know, it's something we can maybe talk at another point in time, but that's the issue.
Oh, I see. Okay. You're fixing the VPN or are you fixing Office?
It's how you talk to Office when you're running VPN.
I see. Okay, thanks.
Yep. So, Google has their cloud ecosystem. The Google Calendar, Google Sheets is the equivalent of Excel. Google Slides is the equivalent of PowerPoint. Google Docs is the equivalent of Word, and of course Gmail. So there's a Microsoft ecosystem, there's a Google ecosystem, and then there's the Apple ecosystem, which is the iCloud system. And the iCloud system actually has a lot more features. The whole music thing with iTunes. And so forth. And so, but anyhow, these major companies have these ecosystems that are all cloud-based that provide a lot of different functionality. And I use this as an example. Before I retired, I was a Windows individual, and when I left the corporate world, I converted to Apple. So I've kind of seen them both. But the cool thing about Apple is that whether you're running a Mac, whether you're running an iPad, or whether you're running an iPhone or Apple TV, you can interface to these different systems. And we'll talk about that a little bit later when I talk about photos. So there's just a little sample of the cloud applications. So you can see they have an equivalent for email, calendaring, documents, spreadsheets, presentations, and so forth. This isn't comprehensive, but the point is that you can do all of these things with just a browser or a tablet. You don't need to install any software on your computer. So cloud storage. So cloud storage is, again, if you don't want to do all those other things and you just want to store stuff out in the cloud, you can do that. It's very secure, and it presents accessibility. And we'll talk about that, and allows you to collaborate. And so, for example, these are the major online storage players. You may have heard of Dropbox, or you may have heard of Box. There's Google Drive within that world. Apple's iCloud has a storage facility. What these are all about is, for example, I run Dropbox, and in Dropbox, and I'll use my son as an example. And earlier in my son's life, when he was working, I would do his taxes. And so I had a Dropbox account, and I set up a folder that was shared with my son, who lives in San Francisco. And so he would load documents into a Dropbox folder that were the information for me to do his taxes. And so you can use Dropbox as a way to share information out in the cloud that you can allow, and you can have, like, I have an account and I share one folder with one group of people and another folder with another individual, and so forth. So it's an online storage capability that's out in the cloud that multiple people can share. And we were talking about Microsoft 365, Microsoft OneDrive, that's the storage environment that comes with that environment. And then there's backing up your system. And it's interesting, in working on this preparation for this class, I'm making this conversion. So benefits to backing up in the cloud: it backs up in the background. So you set it up on your laptop or your machine, and in the background, it copies the files up to the cloud backup service. It'll carry multiple versions of a file, but it allows you to get at those files anywhere. It's highly secure. And so the traditional thing, and I'm a perfect example of this, on the left, I have a laptop and I have a little mini drive. And because I'm an old IT guy, I keep the drive in a safety deposit box. And every 3 months, my wife has on her calendar a little reminder, says, go get the drive and bring it home and back up your laptop and back up her laptop and put it back in the safety deposit box. Well, that's an old way of doing it. And maybe the safety deposit box is extreme, but like I say, I'm kind of an old IT guy. But now you can, with the cloud, you can sign up for a backup service and have your device backed up all the time. It's always current. You don't have to worry about it, but it's always accessible. And there's a variety of companies that are out there that do this. iDrive and Backblaze are kind of the couple of the highest rated ones that are out there. You might have heard of Carbonite. They've done a lot of, if you listen to NPR, they historically have done a lot of advertising there. But you can see some of them have a little bit of free capacity, and then based on a certain dollar amount, you get a certain amount of capacity, and you can back up your devices. And so that's a pretty cool thing, and it's pretty simple.
Hey, David, can I catch up on a couple questions?
Sure.
There's one that was from about 15 minutes ago. You may have already addressed it, but you might have had a slide up on this. Where does Apple fit into the cloud marketplace chart? And again, if it's not important, or you're going to get back to a different time?
No, that's an excellent question, because I I know the answer, but I didn't think about it. It's not on the graph. So Apple's cloud business is for individuals. They aren't big in the iCloud market for businesses. And that particular chart was the cloud providers for businesses. And so that's why you didn't see Apple there. Apple has focused their business, their cloud support, and the whole iCloud thing around individuals. And so that's why you didn't see it there. Great question.
Okay, there's a couple other technical questions, and then I'll save one at the end that I think is a bigger conversation. But what does VPN mean?
Okay, VPN stands for a virtual private network. And what that is, and Tom was talking about that, when you establish a connection across the internet, in theory, people could look at your conversation. If they had the right tools and were in the right place, it's not easy, but in theory, your information, depending on the application you use, could be exposed. Now, a lot of applications have security, but in general, if you want to talk to between your device and another device, VPN, once you enable VPN, you set up an encrypted connection. Instead of your connection being open and not secure, it encrypts everything that leaves your device to between your device and the endpoint that you're talking to. And so any conversation that's going on between you, your machine, and the destination is encrypted, and they call it a tunnel. A VPN tunnel is you're communicating, and it's called a tunnel because nobody else can see inside of it. It's just, it looks like a bunch of bits going by, because you have to have the security, the encryption keys. The only people that have encryption keys are your device and the other end of the VPN. And so that's what that's for. And that conversation could go on for quite a while, but that's a summary of what it is. Okay,
I'm going to let you proceed. Peggy has a couple questions, but we're going to address them at the end. I think they're not pertinent to what you have up on the screen right now, but okay. We'll get to them.
All right. I always joke, there was a great commercial that was on years ago. I think it was by Walgreens, trying to support their photographic service, their printing service. It showed a picture of a kid. It's like somebody in the family is taking a picture of a kid jumping off a diving board into a swimming pool, and it freeze framed the kid when he was in the middle of the air, and said, "Has this picture ever gotten off your phone?" And so photos are a really interesting thing, and as my wife will tell you, I spent a huge amount of time for probably 10 years going through and digitizing our photos. In fact, I have a HASP class that when we can all get back together on digitizing and archiving your photos. The cloud is an excellent place for photo storage and management. It's very secure. You have digital photo albums. I will tell you that a tablet is about the coolest digital photo album you could ever have, because you can sit around and thumb through the photos and view it like you would a photo album. And so loading up and organizing your photos in a cloud management tool is a really outstanding thing to do. And you can add context. And if you're a crazy person like me, we scanned all of our photos. I adjusted the dates, so the dates represented as best I could when the photo was taken. I went and geo-tagged them, meaning I figured out on Google Maps or a mapping system where that photo was taken as best I could, and added a description if I could, and then did facial recognition. So once you've done that, and I've done that for all the photos from Sue and I since we started dating, whatever photos we had, and combine that with all the photos that you take with your phone, and put that in a cloud service so that you can look at it on a laptop, look at it on a tablet, look at it on your phone, or put it up on your TV. It's a lot of work, but I will tell you that the effort has been wonderful, because anytime we're anywhere and somebody's, we're down with our daughter, and her granddaughter wants to see what her mom looked like when her second birthday, we can bring it up on her phone. So that the photos are accessible anywhere, and they're accessible, I didn't spell it right, but they're accessible on any device. And I happen to use the iCloud service. So with the Apple TV, you can look at your family photos on your TV, and you can do searches and say, hey, what did we look like when in 1987, and so forth. And so it's a really powerful thing. And there's lots of photo providers out there. That are some for professionals that have much higher resolution services. The reason I highlighted Amazon Prime is Amazon Prime has a photo service, and if you spend $120 a year for the Prime service for retail, for the reasons that you would do that, photos comes along with the deal. So anyhow, I'm a big proponent of using the cloud for storing photos. Music in the cloud. So this is another thing. I'm kind of a big music guy, and the cloud is a great source of music. Music streaming services, they have digital copies of enormous numbers of music. And I mentioned podcasting here. I'm not really going to talk about that. That's a whole topic in and of itself. But there's an incredible variety of music, depending on, I love classical music. I love jazz. I love rock. I love metal. I'm not a country guy, but all those genres are out there. So it's incredible variety. And I have a collection. I have about 1,000 CDs, so kind of a nutcase, but you can take that collection, digitize it, and then integrate it with these services. So it's incredibly convenient, and it's very affordable. And so the chart I included here shows that 29%, this was done in May 2019, how people listen to streaming music. 29% on the radio, 27% on their smartphone with headphones or earpods, whatever, 19% on their computer or laptop, 8% had it connected to their household stereo system, or they were playing it off a turntable. And anyhow, you can see smart speakers and so forth. So it is very much a real thing, and it's a great service. And I thought I'd throw these in. I wish they had gone back to further in time, but if you look at the upper right, you'll see what vinyl was back when we had records. You see the little sliver for 8-track tapes, and then cassette era, and then the compact disc era. And then you see MP3s and ringtones and streaming. And so these are looking at the music industry and their revenues. And so if you look at the right-hand side, you see kind of a more summarized view of back when it was physical to look at music versus digital. And so the digital streaming thing, and again, I could only find these slides through 2017, but it's grown incredibly. If you look down the center, the major players that in 2019, Spotify, you can see was at 35%. Apple Music was about 19%. Amazon Music was 15%. The various Chinese companies were about 11%. And YouTube Music was about 6%. Now, one thing about YouTube Music is you can go out to YouTube Music and see performances for classical, jazz, rock. I mean, any sort of entertainer that you're interested in, you can go out and find on YouTube and watch a video of them performing in a particular environment. These are all the cloud music services. Some are super high quality audio file. In fact, Spotify announced that they're going to offer an audio file quality Again, there's a whole nother topic that getting into the quality, but you can see huge amount of music that's available out there. Some specialize in classical music and so forth. So clouds is another great thing. And then finally, we get to movies in the cloud. And so similar to what's happened to the movie industry, in these cloud data centers, they have digital copies of the music, of the movies, and you can find any movie that you want. There's various ways that you can bring it to your TV. Many modern TVs now have an app in there for Netflix or Amazon Prime. You can use Apple TV, Roku. There's a variety of different services that you can connect to your TV and watch movies in the cloud. And it works really well. There's a bad side though. So here's some of the major services. Disney Plus just came out a year ago, and now there's what is it? Yeah, there's Paramount Plus, and the one I was thinking, Discovery Plus.
Peacock.
Yeah, a Peacock. Yep, yeah, and so my comment about all of this, and here's the different, some of the different the big ones. My comment about all of this is, so some of it's in response to cable TV and people complaining about price they pay for cable TV. But my comment is, it's getting incredibly fragmented, and so everybody is trying to get into the game. Everybody's trying to get their, X dollars. If you're an HGTV fan, which my wife and I are, all of our favorite shows are being moved to Discovery Plus, and there's a lot of great stuff on Discovery aside from HGTV. Don't get me wrong, but again, you're going to have to pay for it. And so we subscribe to several of these services, but it's going to be interesting to see what happens over the next several years. Is all these services come into being. I got to believe there's going to be a shakeout because it's getting so fragmented, and it's frustrating for, you want to watch a movie if you're a Bogart fan and you want to watch The Big Sleep. Which service is it on tonight? I don't know, and so figuring that out, and there's tools to do that, but it's not a trivial process. And then this last slide I just kind of threw in here. There's all kinds of utilities on your phone. There's all kinds of apps. And are they running in the cloud or are they not running in the cloud? If you consider the cloud the whole internet infrastructure of things, yes, you can say so. But when we were providing services to customers, some of our apps ran out in the cloud. Some of them ran on a server in our computer room. And anybody can create a service and put a server in their basement and provide a service. So is that the cloud or not? If you consider the cloud the whole of the internet, I suppose so, but it doesn't necessarily mean they're running in these big, what I call cloud data centers. So to summarize and wrap up here, the point in all this is this has all become possible because of incredible communication speed that fiber optics has brought to the environment, the building of the internet that makes it so pervasive and so accessible, and then the incredible processing speed of computers that allow us to build these massive data centers and put an enormous amount of computing power. And when the communication speed allows you to get at it from your smartphone in your hand, driving down the freeway at 70 miles an hour. It's been a huge change for the technology industry and for our society in general. I didn't talk as much about storage performance, but as I showed those pictures, I could have talked about the capacity to store information from what it was back in the day to what it is now. So just like there's been enormous improvements in computer speed, there's been enormous improvements in storage performance. So all these things have made the cloud a concept and a possibility that is available now that 10, 20, 30 years ago wasn't even conceivable. So that's kind of my story, and I'm sticking to it. And I'd be happy to entertain questions. And
Let me
hopefully-
ask the two quick questions that were in the chat and then open it up for discussion. Peggy asked, can you address the hack that occurred with SolarWind?
Yes, I can. In fact, in that chart, SolarWinds was on that chart. And I will tell you, when I was responsible at Spartan Nash we had a network with about 10,000 devices on it. We were a big user of SolarWinds. And so that's a huge exposure. I can't tell you all the details, but we all installed SolarWinds. It has a cloud component and it has an installed component. And it, presumably it was the Russians. You can read forever about all of that. But what they did was they got access to the software installation server that SolarWinds had. And so they were able to put modify the software that was running in the cloud and was running in people's data centers. It was a very shrewd, as a hacking thing. Hacking and security, that's a whole nother topic that we could talk about sometime. But it was a very ingenious strategy to gain access to a whole lot of corporations. Now, how many corporations did they actually look at? And the government, SolarWinds is the gold standard for network management. And it's got to be a huge damage to their reputation. But by getting into the installation with server where they kept the gold copy of software that was installed in all these companies, and the fact that they got the compromised software in that server was huge. And so and as a SolarWinds customer, you're installing updates on a regular basis. It's a coordinated thing. You don't do it casually, but yeah, that was a huge deal. We don't have time to go into more details, but it was as a technical person, it was a very intriguing strategy that they took they were able to get into the distribution copy of that software, and therefore companies just installed it at will, not realizing that the software was compromised.
Thank you. We have a lot of activity in the chat now. Why don't you go ahead and stop sharing your screen? Unless you're going to go back to the presentation, then everyone can see each other. And now that we've opened it up, folks, I'll read the questions in the chat, and then after that, you can just unmute yourself. So there's a couple that are related. If the photos on my iPhone are stored in the cloud, can I delete them from my phone? And then as an adjunct to that, I would say, someone else asked, what's the best way to learn to get my photos from the cloud? I have an Apple computer.
Okay, two good questions. So first of all, when you do this, and I guess I need to go back. I've the class on doing photos. It's about 3/4 developed, but we're waiting till we can be back in the classroom to do it. But what you do, so as I had that diagram up that had the laptop, a tablet, a phone, and the Apple TV doesn't really matter much. What you do when you tell iCloud that you want to synchronize your synchronize your photos, you declare where the master is. So in my case, I said my laptop is the master. And so what iCloud does then is it replicates that master to everywhere else. And I can, if I delete something on my phone, if I delete something from the master, it's deleted in the cloud, and so nobody can see it any longer. If it came from my phone, and that was the origination, in other words, I took it with my phone, that gets replicated up and a copy gets put on my master on my PC. But if I delete it on the phone, it's deleted everywhere. So in essence, the phone, where you're creating the pictures, you have control of the pictures you've created there, and then the master is where it's kept. And in other words, I could have said the master is in the cloud. I didn't want to do that. I'm kind of an old school guy, and so I said I want the master to be on my laptop. So hopefully that answers that part of the question.
Okay, can you discuss linkages further? For example, how the satellites work with fiber optics.
Okay. Let's talk a little bit about, so it depends on when you talk about satellites, I got to be careful how I present this. So satellites, an awful lot of communication doesn't, so I'm going to talk about SpaceX and their satellites separately. Historically, most satellites that do communications are in geosynchronous orbits around the Earth. That means, and I haven't thought about this stuff in years because I haven't done satellites since the 80s, but I think it's 22,300 miles above the Earth is where it's a geosynchronous orbit. So you put a satellite there and synchronize it with the turning of the Earth, and the satellite is always at the same position on the Earth, over the Earth, excuse me. So it has an orbit around the Earth that's synchronized with the spot over the top of the Earth where it is, and they're typically at the equator, aligned with the equator, so 22,300 miles up. The problem with that is, is the latency, the amount of time it takes to send a signal from your house, let's say, up to the satellite, and for it to propagate back down. I can't remember, again, I haven't done this in years. I want to say it's a 1.5 second delay. And so if you're interacting on a computer and so forth, it's untenable. It doesn't work. It's not good. Now, some people have internet access that is only available because of geographically where they are. Is only available with satellite, and the satellite companies do some games and so forth to make it so it isn't as cumbersome, but it's slow. And so when you talk about the internet, satellites generally aren't involved anymore unless they're in remote locations. Like that diagram I showed of the backbone of the internet, it's all fiber optics. And so, but when you get to an endpoint, you can convert, and again, I go into a lot of technical detail, bore you to tears, but you can connect up to the satellite and move the data through. Now, if you're paying attention, if what your question is asking about what Elon Musk is doing, he's putting, I think it's 64 satellites at a crack up when he launches a SpaceX rocket. They're putting satellites in low Earth orbit, and I think it's going to be 1,000 of them, or 1,200 or 12,000. It's a large number, but the idea is to provide internet access anywhere on the surface of the Earth. Now, there's a whole nother topic of astronomers aren't too happy about this because they're putting a whole lot of dots up on the sky. But in that particular case, because the satellites are closer to Earth, you don't have that latency problem. And so things are much more responsive. And so connecting up to a satellite link, you need a switch, a router, and a couple of connections, and away you go, and you're running TCP/IP. And I probably don't have enough time to go beyond that, but there's a way to do it. But satellites, they used to be used for communication across the ocean. Now it's all done with fiber optics.
Great. What are the edge points of a presence?
Okay, well, there's a couple of different ways you talk about that. So if you get service from AT&T or Spectrum or Comcast, I'm not sure exactly what the person is asking. So there's the edge of the network, and that is generally defined by the edge of the provider's interface to you back to the internet. And so you have a connection in your house, and that would be considered the edge of the network. And then you would connect your devices into it. Beyond that, I'm not quite sure of the question.
Okay, we only have a few minutes left, and I would like to ask, this is a really important one, and we've touched on a lot of this in our curriculum. As the world population increases from 7 billion up to 9 billion, what are the data center power use ramifications for climate change? Should people be required to trash more old emails and files more frequently?
That's a great question. So what I would tell you is that most of these cloud service providers are very climate conscious. because these data centers take an enormous amount of power. I mean, that could be a whole nother class by itself, but most of them have committed to trying to get to as close of a zero footprint as possible. So they buy up renewable energy credits, not credits. They'll locate. I mean, the ones in the Northeast, they're all make sure they're driven by hydroelectric. There's data centers in the Nordic countries that are buried underground because it's so cold. They don't need to heat them, or excuse me, they don't need to cool them. So the general comment I would make is it is an issue, but I would tell you that most of the companies that are involved in this that I know about are very climate conscious because they understand the impacts. And again, we could have a whole conversation about things that I know that they're doing to try and make things as efficient as possible.
I may have a question somewhat related to that.
Yes.
You talk about the size of these data centers or the cloud data centers. It would seem you could put the country or the world in turmoil if an adversary tried to destroy or disrupt service at those centers. I assume, are their locations secret? Is there high security around them?
Yes. Yeah, it's incredibly high security. They when they come into a town, you don't know much about them. And whole data center security, I mean, even in the corporate world, you do a whole lot of things to secure a data center, but they're very nondescript buildings. They use man traps. They use a whole lot of different things to protect their locations. You won't see a big sign that says Google Data Center or Apple Data Center. I've been through the old Steelcase Pyramid is now a big data center. And I've been through that, and it's amazing what they do. But then to add to your other question, if somebody said, well, I'm going to drop a bomb on one of these data centers, the way they're designed to replicate information across different locations, the general thought is that most information that's in, I don't know, call it a Google data center, is in 3 locations, and they're spread out. They're not even in the same time zone. So they definitely think about those things. It's a very good question, but they're very conscious about security. And again, that's another topic in and of itself.
So I just Googled man trap for anybody who wants to know.
Oh, sorry. So
that's okay. It's straight out of a movie. It's a man trap, airlock, Sally Porter access control vestibule is a physical security access control system comprising of a small space with 2 sets of interlocking doors. So it looks like basically like a safe room, correct?
Yeah, well, so the way it is, it's like a doorway to go into a room. There's 2 doors, and you go through the first door and it locks behind you. And until that door locks, you aren't allowed to go through the next door. So they have to, once you're trying to get in, it's, I can't remember the term we used to use of somebody walking in behind somebody else.
Tailgate.
Tailgate, that's it. Thanks, Brad. You would know. Those are things you do to prevent tailgating to go into these rooms. Mm-hmm. And these, even in the corporate world, there was always a joke. We had a new CEO come in, and the first thing when he came down and toured the IT department, he swiped his badge on the computer room door and it didn't open. And he said, well, how come? I said, you're not allowed in there. and I kept my job, so that was good. But there's a whole, it's a whole science in and of itself. Having built a couple data centers, it's an interesting topic.
Does anybody want to unmic themselves or unmute themselves and just speak up? It's 2:32. Do you have a few more minutes if there's some questions? We have a couple more in the chat that as people are formulating. Let me ask a couple more and then just unmute yourself and jump in when I'm done talking. Regarding hacking by adding software to an app, why wouldn't an old-fashioned checksum flush that out? I'm not sure what that means.
That's a very good question. So for everybody on the call, the checksum is a method where you take a look at, it's used in lots of different ways. It's used on, you're running Wi-Fi, the Zoom calls running checksum and so forth. And basically what it says, when you have a block of data, you do a mathematical calculation on the bits, the ones and zeros on that block of information. And you create a unique number that if any one of those bits change, that numbers won't match any longer. And so that's absolutely correct. Yeah. And if you were trying to put the software in after it had been turned into a load module or code to be loaded, that would be effective. But in this particular case, the hack, they were able to get into the source software and modify the source software that was on the distribution library server. And so it just looked like code. Now, obviously, your question is still valid that SolarWinds checking process wasn't good enough to catch the fact that somebody had modified it. And if I remember right, I believe from what I've read, and this is so common, is that when you have a security issue, the most common thing is when somebody gets your credentials, somebody gets the ID and password of a real person that has authorization to get at that server. So that's what they did. Somebody from Russia or wherever they were had the real ID, the real password and ID of a legitimate person that would normally be working in that code, and they went in and modified the code, and so nobody was the wiser. And so that's how you can get around a checksum issue. Checksum's a really low-level thing. There's other hash methods and so forth that are more sophisticated. But don't get me wrong, checksums, everything we're doing has checksums involved with it, but there are other methods.
So Michael has asked, what reason, if any, is there to have Dropbox in addition to Google Drive or iCloud?
Oh, not necessarily. If you have, example, if you had Google's Drive, you can do the same things you can do with Dropbox. iCloud is a little bit more limiting in terms of the Apple sort of ecosystem, if you will. For example, I'm big in iCloud and big in Google. I don't use Google Drive, but I do use Dropbox, and I use Dropbox for sharing for other purposes, my drone files and other things and so forth. So your point is valid. If you have a Google Drive, you wouldn't necessarily need Dropbox.
Okay, that's all I have in the chat. Does anybody want to open up their mic and ask a final question? We are about 5 minutes over right now.
Well, I guess
okay, this is Judy Zielman. Hi, David.
Hi, Judy.
Thank you. I have a really, really simple question, I think. I have a Android phone, and I use Gmail, and I have about 1,100 contacts.
Oh, yes.
And when I change any information in my contacts, I cannot get rid of the information I changed. It stays there. Now I can default to the new one I put in, and that helps. But how in the world do you get rid of the information that's no longer pertinent?
So I don't know about your particular situation, but what I would look at is you can use the Contacts app in Google, in Gmail, and you can synchronize that with the contacts in your phone. So that's a configuration issue. I can't answer that on the phone, but there's a way to do that. So, you can contact either your cell phone provider would be able to help you. There's different ways you could get that done, but that's what you need to do.
Thank you. It's just a little frustrating.
I'm sure it is. And knowing you have a lot of contacts.
That's how I keep in touch. That's wonderful.
I'm sure it is.
Well, Dave, we appreciate so much your contribution today. I think everybody would agree. It's very interesting and informative. Yes, I see claps going up on the screen. So thank you. And thank you, Susan, if you're still in the back.
I'm still here. I'm just lurking around.